Good morning, everybody. Thank you for tuning in, watching the video today. It's a smart choice, always is. Watching these videos, it's the best thing you can do to just make sure you're understanding the math. Knowing how to do this stuff is all important, but if you really want to remember it and, be the best you can be at math, you need to really try and understand why these things we do work. Because it's all for a reason. None of this stuff works just because I say so. I promise. I'm not the first person to figure this stuff out by any stretch of the imagination. Right? The people have been doing math like this. They figured it out thousands of years ago. The Greeks were solving math, basic math. It didn't, it took until Newton to come around to really add calculus into the mix. So this has been going on for a long time. It's a very, very useful tool. So that's what we're going to start off with today. We're going to focus on the why, and then I'll show you some example problems of how to do these specific ones from the IXL. So I want you to direct your attention to the question we're working with here. So this is from your IXL assignment today. Your assignment will look like this. So let's get back to it. So these type of questions, they're kind of walking you through how to solve these two-step equations. And these are called two-step equations actually for a reason. Right? It's not necessarily an official math word, but they call them that because it only takes 2 steps to solve them. Last week we were working on one-step equations. All you had to do was add, subtract, multiply, divide. It depended on the type of equation, but that's all you had to do, and then you found the answer. Two-step equations, well, it's 2 one-step equations put together. And there's just 2 steps to solve these. So first, let's think about the order that we're going to solve these. So in the Math Antics video, he talked about how you work with order of operations kind of backwards when you're solving equations. And it's a great reference to solve equations like this. So if you're not sure where to start, well, you can always think of Pemdas. Please excuse my dear Aunt Sally. Well, this stands for parentheses, exponents, multiplication and division, and then addition and subtraction. So first off, let's go through this. I know it kind of gives us this tip here, subtract 1 from both sides. Let's think about why, though. So we look at PEMDAS and we see, okay, addition and subtraction comes first. You look up at this equation, and we know we're multiplying 3 times u, but we're not at multiplication yet. We have to do addition and subtraction first. So we're going to start off, we see we're adding 1. And now we want to think about what will happen, or what we want to do with that 1. Well, you want to subtract it away from both sides, because the whole goal here is to get u all alone by itself, just like you see down here. You get your final answer when this is all alone, with no friends next to it. Okay? So we need to get rid of these numbers over here. So first we get rid of the 1, because that's what we saw here. We're adding 1, so we're going to get rid of 1 first. To do that, you take the opposite of addition. The opposite of addition is subtraction. That's why it says subtract 1 from both sides. So what we're going to do is basically subtract this block away, so it just leaves us with these. But then we're going to have to do the same thing over here so that the scale doesn't go out of balance. That's what you're going to see. So step 1 of our two-step equation is that we're going to subtract 1 from both sides. Notice we took that yellow block away that I had up here. Alright, the 1 block. We had this 1 extra block up top. We took those both away. It stays level, stays balanced, and it leaves us with 3u is equal to 15. Now I kind of showed you the next step, but it's okay. We're going to still think about what we should do next. So now we have 3u is equal to 15. Remember, this is really 3 times u. So again, we have a one-step equation here. So we want to take the opposite of multiplication. The opposite of multiplication is division. So we can divide this 3 away from both. Divide 3 away from this side, and then we divide 3 away over here. But how does this work with the blocks? Let's think about it a little bit. So we're dividing these into 3 groups. We're dividing these 15 blocks into 3 groups. Right? We're trying to split these blocks up so that there's an equal amount in each one of these. So you can see, I just took that 15 from up here and put that down here. So we took the 15. Notice I split it up into 3 groups of 5. So we know that, well, there's 3 blocks here, 3 U blocks, and if we are splitting them up into 3 equal groups, that means that there's going to be 5 of these blocks in each of these U blocks. Right? We have 3 of them, so if you divide these up, it tells us that, okay, there must be 5 in each one of these. Or if you want to think about it with weight, we figured out, okay, well, if this side is 15 pounds and it's equal to this side, it's equal to 3 times some number, well, we know that each block would have to be 3 times 5. So each block would have to be 15 pounds, or 5 pounds. Sorry, each block would have to be 5 pounds because 3 times 5 is 15. So that's what we're doing. And this leaves us, we split each one, and we leaves us with just u. So u is equal to 5 blocks. And then finally, for the IXL, you would just put in your answers here. Right? We subtracted 1 from both sides. It left us with 3u on the left. And then 16 minus 1 gave us 15. And then we divided both sides by 3. Okay? Dividing this side by 3u by 3 gave us u. Dividing 15 by 3 gave us 5. So that's why this works. That's how you can think about it with a picture. I'll post these so you can take a look at it. But let's look through some more IXL questions. So we went ahead and solved this. We had subtracted 1 from both sides, and then we divided both sides by 3. So we got u is equal to 5. Alright, let's take a look at this one. So again, I'm not going to go through everything because it was talked about in yesterday's video, but let's, I guess we can think about Pemdas, but I won't go through the whole scale for this one. So we have Pemdas, just as a reference. So first we need to decide where to start. We're adding 9 on both sides. We know addition and subtraction comes first. So first we're going to try and get rid of this 9. So we have c over 18 plus 9. We know that's equal to 11. If you subtract this 9 away over here, well, you know that 9 minus 9 is 0. Use a different color for that. Subtract these both away because this is 0. But then we have to do the same thing to the right side. 11 minus 9 to the right. Right? This is like if we took 9 blocks off the left side of the scale, you have to do the same thing to the right side. Otherwise, it's not in balance. So this leaves us with c over 18 is equal to 2. Now from here, we have another one-step equation. Okay, so we subtracted 9 from both sides. That left us with c over 18 is equal to 2. Now we need to multiply both sides by 18. So that's because we're dividing c by 18. The opposite of division is multiplication. So we multiply both sides by 18. And this will give us 2 times 18 is 36. But what happens to the left side? Well, on the left side, we have 18 divided by 18. 18 divided by 18 is just 1. So those cancel out. They go away. It's just equal to 1. Anything 1 times c is just c. Right? It's like if you had that 1c block on there, on the scale. So this just leaves us with c is equal to 36. Let's try that out. Okay, so let's skip ahead. It won't let me. I'll just do it quickly. So we're going to subtract 7 from both sides. So we have 9d plus 7 is equal to 7. Remember, we start off with addition and subtraction. So we subtract 7 away from the left. We subtract 7 away from over here. It just leaves us with 9d. And then we subtract 7 from the right. 7 minus 7 is 0. And then from here, our second step is to divide both sides by 9. All right, we want to get d by itself, so we need to get rid of this 9. We're multiplying by it, so we divide both sides by 9 because that's the opposite of multiplication. Divide 9d by 9, that gives you d. Divide 0 by 9. Anything divided by, or we have 0 divided by anything is 0. So that's all you have. Alright. So subtract 1 from both sides. Again, we'll do this quickly. Subtract 1 away over here. Well, we have plus 1. Subtract 1 away. That leaves you with just d over 7. But then we have to do the same thing to the right. 11 minus 1 is 10. And then from here, we need to multiply both sides by 7 because we're dividing here. D divided by 7, well, we have to take the opposite, multiplication, and that leaves us with just d. So we have to do it to both sides, so it goes away on the left. On the right side, we have 10 times 7, which is 70. Alright, let's see if it lets me skip ahead now. Oh, actually, this is fine because now we have to fill this out. So let's work through this one. So we have x over 18 plus 1 is equal to 1. So again, we need to think of Pemdas, especially now that we need to write in the steps. So you need to think about what you're going to do first. First, we have addition and subtraction. And we need to get rid of this 1 here. So how do you get rid of it? What do you think we should do to both sides? Why don't you pause the video and think about it right now? Welcome back. So you should have said that we need to subtract both sides by 1. And we're going to subtract 1. So subtract 1. I'm not going to write out the whole thing. It probably says from both sides though. So we're going to subtract 1. Subtract it over here. So we have to do the same thing over here. Because these canceled out. Left us with just this. 1 minus 1 is 0. So you should have a 0 here. Then from here, we need to think about the final step. Well, we're dividing, right? We're dividing x by 18. So we need to do the opposite of dividing. We need to multiply by 18. Multiply 18. And then, so on the left side, we do times 18. These cancel out. Then on the right side, we do 0 times 18. But again, anything times 0 is just 0. So that must be x. So let's go back. So we said we need to subtract 1, and then we need to multiply. So this gave us 0 and 0. Alright, let's take a look at this one. So we have d minus 8 over 3 is equal to negative 16. So this is a case where we're working with parentheses, actually. They don't write them in, but whenever you have an expression in the numerator, like d minus 8, there's always parentheses there. You just they don't write them in. So we're going to do Pemdas again. Think about the order we should do things. Because normally you would do things in parentheses first, but now we're doing them last. So we're doing Pemdas backwards. Now we have subtraction, you see, but that's inside the parentheses, right? This is inside the parentheses here. So this means we need to save inside of it for last, right? Parentheses kind of change the order of things. So we're saving this for last now. So what comes first, actually, is we're not doing addition or subtraction first, but we're dividing by this 3 here. So we have division next. We're dividing by 3 on both sides. So what we can do is the same thing as we did before for the other questions. D minus 8. We said that's in parentheses over 3 is equal to negative 16. Well, since we're dividing here, we're dividing by 3. Well, we're going to take the opposite of division, right, which is multiplication. So we're going to multiply both sides by 3, just like the other questions. We're going to multiply this side by 3, which is going to cancel out with this, right, because this is in the numerator, this is in the denominator. We're going to do the same thing to the right side. So this will give us negative 16 times 3, which is negative 48, is equal to d minus 8. So that's what we'll write up here. And what we did is we multiplied both sides by 3, so that'll go here. And then finally, we have one last step here, right? We're subtracting 8 on the left. So to get rid of this, we take the opposite. We add 8, which cancels these out. Because 8, we have minus 8 plus 8 is just 0. So that leaves us with D here on the left. And then on the right, we have to add 8. And we did it to the left, so we have to do it to the right. Negative 48 plus 8. Be careful, you're working with a negative. Negative 48 plus 8 would be negative 40. And so this is what I mean when you don't want to get these negatives wrong, because if you did all this work up to here, you don't want to get it wrong just from that step. So this is D is equal to negative 40. Let's try it out. Negative 48, negative 40. Our first step, well, we said the top was in parentheses, so we saved that for last. Right? Even though we were subtracting, we saved it for last because up here the whole top was in parentheses. Even though we don't write it in, we know it is because all expressions in the numerator have parentheses around them. So we multiplied both sides by 3 to get started. Multiply both sides by 3. And then from there, we had just D minus 8. So we added 8 to both sides. And then we were done. Alright, this will be the last one I cover for today. Okay, so we have negative 3 times the quantity of C minus 5. It's all equal to 9. So again, Pemdas. We have parentheses again in this one, which we know we're saving for last. So let's look at this here. We start off with addition and subtraction. There is subtraction, but it's in the parentheses, so that's actually being saved for last. We know we're multiplying this 3, negative 3 outside, by everything in parentheses. So we have multiplication and division come next. And then there's no exponents. You're not going to really see these in today's IXL at all, but I'll just fill that in. So again, addition and subtraction we look for first. This is inside the parentheses, so this is actually being saved for last, right, because we're going in this direction. Multiplication and division. Well, this negative 3 is being multiplied by everything in parentheses. There's no exponent, but there is parentheses. So what we'll do last is handle this. So the first step we're going to do here is, well, we're multiplying negative 3 on this side. So since we're multiplying, we need to do the opposite of multiply. We need to divide this side by negative 3. So we divide by negative 3 over here. I'll write that back in, but all right, we're dividing by negative 3. Actually, let me rewrite this. There we go. So we divide by negative 3. Divide by negative 3. And then since these are the same number, right, negative 3 divided by negative 3 follows the same rules, right? That's just 1. So that goes away. So that leaves us with just C minus 5. There's no need to write parentheses anymore. They went away. Now on the right side, we have 9 divided by negative 3. 9 divided by negative 3 is negative 3. From here, it's just a one-step equation. We're minusing 5, so to get rid of that, you add 5 to both sides. So these cancel out. This leaves us with just c on the left. And on the right side, we have negative 3 plus 5, positive 2. So that's what's going to go here. And then let's see, after our first step, when we divided this negative 3 away, it left us with just c minus 5. And we knew that was equal to negative 3. And probably the best way is to fill this out just as you go along, but I kind of got caught up talking about it. So what we did first is we divided both sides by negative 3, as we knew we were multiplying here, and the opposite of multiplication is division. So we divided by negative 3, and then after that we had to get rid of this minus 5. So to get rid of minus 5, we could add 5. The opposite of subtraction is addition. So you just add the 5 to get rid of it. But then we had to do the same thing to the other side. Negative 3 plus 5 gave us 2. So that's what we did here. We added 5. We'll fill that in, and we should see that we are correct. So first we divided both sides by negative 3. Then we added 5 to both sides. Alright, so hopefully you found this helpful today. Hopefully two-step equations are becoming a little more clear. I did expect they would pose a little bit of a challenge, especially doing it online, but it's just that type of thing where you just need to practice. That's how it is. That's how it is even in the classroom. It's just one of those things. It's a little confusing at first, but once you get the hang of it, it becomes much easier. And really just the best way to learn it is just practice, practice, practice. So that's all I have for you guys today. Thank you for watching. Please take care.